Alright, so this is the intro to Mikrotik. Kind of the basics, quick getting started. How would you do kind of a default config on one of these guys? Hopefully you've gone through my intro to networking class so far. And the video should be up by now. To kind of get some foundations. Hopefully you have kind of a CCNA level foundations, what I'm kind of shooting for with this, because I'm not going to spend a lot of time on theory. I'm really just going to jump right into configurations. And also, even within these slides, I'm going to kind of skip around. So a lot of the basic stuff, I'm just going to kind of move past it, try and keep this class as short as possible. So, let's see. Starts out, my slides, terms used, blah blah, you guys know all that good stuff. Connecting a router. That's what I'm going to start with. And so there are a couple of ways to connect. One, with most devices you have a serial option, except for like the 750. RV750 doesn't have a serial port, nor does I think one of the 411s, the really inexpensive guy. Default password is admin. No, or rather default username is admin. No password. And so this is the command line interface, which is really great. You want to move around. Question mark will show you kind of a list of all your options. The light blue is going to be folders. The purple is going to be commands. So if you want to look at the IP address, and then print. Instead of show like in Cisco, it's print. And so you can see I don't actually have any interfaces. I believe this guy's a 411 that I'm plugged into right here. My wireless AP. And you can also connect with Winboxes, which is the tool that most people are going to use. You hit this little box with the triple dots, and it'll look for all of the devices, all the Mikrotik devices on your directly connected subnet. I want to connect to this 750 right here. Connect. And as you saw, I chose the MAC address, and what that's doing is connecting with MAC telnet, what it's called. So it actually just does layer 2 to the device, which is super handy. If for some reason a firewall rule you lock yourself out, a lot of times you can still plug into the same directly connected subnet and MAC telnet into this guy. So it gives you kind of a back door. Or if you're going to do something that's completely a wireless bridge, you don't even have to put an IP on it. It doesn't even have to be manageable. You can just MAC telnet in from the closest router. So let's see, you've also got your normal options, your SSH, your telnet, so you can usually connect. You can connect in a multitude of ways. You can even do FTP for file transfer. Let's see. Oh yeah, and for that triple dot trick I did, to be able to see that, guys, you have to have IP neighbors enabled on that interface. Just a little tip. If you've turned it off, you have to turn it back on to do that little trick. By default, it's on. Let's see, the first real command in here I have listed is safe mode. So I'm going to tell you about that really quick. You open a new terminal, Control X puts you in safe mode. You see safe mode taken popped up right there. What that does is that allows you to make changes to the router. And if for some reason you make a routing change or something like that where you get disconnected and Winbox completely fails, it's going to revert all the changes you did up until the point where you went into safe mode. So it'll revert and you'll still be able to get back into the device, which is really great. It saved me several times, but it's also hosed me up pretty good a couple times too. That being, before I've had some VPN problems. So I went into safe mode, I tweaked and tweaked, made some changes here and there, blah blah blah, and then finally got it working. And so when I was done, I just went up here and clicked the X. So what that does is that's considered a disconnect. You have to remember to go back to your terminal, Control X to release safe mode. So just be mindful of that if you're going to use safe mode, which I'm sure most of you will. Alright, and then the next slide, just going to kind of follow around these guys really quick. NTP client. This is going to allow you to sync the time, and I love this for logs. If something happens, you want to be able to know when it happened, kind of pinpoint everything. So you want to enable unicast, and then I don't actually have any IPs off the top of my head. Then you just say okay. You're also going to want to go to system clock right after that, and put in your time zone. to make your time as accurate as possible. Let's see, moving on, system identity. As you can see, I already put a name on this guy. System identity right there. I'll just name it RB. I'll go ahead and modify that a little bit. So you can see up here at the top says RB750. There you go. That way when you're connected to multiple Mikrotiks, it actually makes it easier to tell which one you're on. And also when you pull an IP via DHCP from another machine, the host name that shows up is going to be that one right there. So that's system identity. System users. This is where you can set up a multitude of user accounts right here. By default it's admin full. You can add additional users, add additional groups, and then assign rights to those groups, what they can actually see and use. Let's see, system logging. This is very important because this is kind of your insight into what's going on. If you're having a specific problem, you can enable that logging for that specific type of problem. So like you're doing VPN, one of the first things you want to do is topic IPsec action to memory, and you say okay. So what that's going to do is whenever you go over here to the log, it's going to show all of your VPN stuff here in the log. All of your phase negotiation, any problems that are going on in there, it's all going to show up in this log. Really, you can see pretty much every action shows up in this log. Another thing you're going to want to do is, what I usually do is I set up one as UPS, because I never plug UPS into these guys. I say UPS, and then I hit this little tick right here, which means not UPS, and I send it to remote. I say okay, and then I go actions, and then remote right here. I set this as my cacti box. I run cacti easy, which can be found from cactiusers.org. It's a great open source monitoring project. I use it in pretty much every site I do consulting for. I install it, or I'll run them off my hosted cacti server. What it basically does is it'll dump all of these messages to the syslog server, and you can alert, or you can go back in time and see what happened, all that good stuff. DHCP client pulls IPs, server hands out IPs, somebody's trying to log into your server and they're failing authentication. All of that information can be dumped back, which can be extremely useful, especially when it alerts you at 2 in the morning that somebody's trying to break into your router. Let's see, DNS server. This is a nice one for a site. Sometimes you can have the appearance of running your system a little bit faster. Let's see, settings, allow remote requests right there. First you're going to put in your DNS servers, but then allow remote requests will allow clients on the inside to actually query you, and you become a caching DNS server right there. So it'll actually speed up DNS requests, or it'll speed up DNS requests because it'll be able to cache them locally as opposed to you having to go out and pull every time. Plus, you'll also be able to add in some static DNS entries if you want to. Alright, so I'm going to show you my basic diagram. This is kind of this guy right up here. This is the guy we're going to use to model our little config on the 750 Opter. So, what I'm going to do is I'm going to kind of loosely follow these slides, just because I like to buck the system a little bit. So let's see if I can squeeze this down a little bit. There we go, so you can still see them. Kind of arrange this stuff. So what am I going to do first? I'm going to put IP address. I'm going to add some addresses. This is going to be that outside interface, and he is 1.1.1.1/30. Now you can fill out the network and broadcast store right there. You can do the slash notation and hit apply, and it'll fill it out for you. And I'm lazy, so that's the way I'm going to do it. I'm going to make that Ethernet 1 indeed. Add me a new one. This guy's going to be 192.168.1.1/24. And we'll just make that Ethernet 2. Why not? Apply. Okay, so we got our 2 addresses. Now, the next thing you're going to want to do is, well, yeah, I've got it in the slides in there. If you have like a DSL provider that's providing you a dynamic IP, you're going to want to run the DHCP client on this guy. So you go IP DHCP client, as you saw. You specify the interface if it was, you know, outside, and then you can. There's a few options in here to make note of: pure DNS, pure NTP, and add default route and administrative distance for that route. By default, you don't have to touch any of that stuff. You can just say OK and go, and that's great. But I also use this DHCP client option looking for rogues in our apartment complexes. So if somebody opens up a rogue DHCP server in my subnet, my Mikrotik will actually pull an IP. And so what I do is I uncheck all of these guys right here, because if you leave it on by default, what happens, default route distance is 0. When I add a static route, it comes in at 1. So this rogue DHCP will actually hijack my route table, and so it'll kind of black hole my traffic. But remember, by default, you can just leave this just the way it is if you're doing your standard DSL connection. So routes, IP, routes, here we are. You see a couple of routes popped in because I configured IP addresses on those interfaces, so there they are. Now I want to add a default route to, we're going to add 000/0 means any address. Gateway is what I use. I don't generally use gateway interface. 1.1.1.2 is going to be my ISP's connection. And that's all I need to do. Apply right there, and so you can see that it specified the interface to leave and everything. Or actually it would if the interface was up. See the static route popped in right there. Another interesting trick you can use is check gateway. So if you're using floating static routes wherein you've got another route to default, say with a different administrative distance. Another cool thing about Mikrotik is you can pretty much copy any command and it'll take it just as it was. Say I've got another default route 3.10 and I want to make it distance 10. What this says is, I'll go ahead and add it. And OK. What it says is administrative distance 1. This one's always going to get used. This one will never get used. If this one falls off the face of the earth, then this one will actually start being used. Let me plug in these interfaces so you can see these routes come up. Boom. See that interface came up? And so did this route it established there. So as you can see, it's not actually able to it's not actually going to be able to ping because I don't have a neighbor. So what I'm going to do is this check gateway option right here, ping. So I can tell this thing to ping this IP address. And if this IP address is unresponsive for X amount of time, it'll actually pull that route out of the route table. Boop. See? Just pull it out. Which means that if this route actually existed, if there was another next hop there, it would go ahead and initiate this route in the route table. Another cool thing about Mikrotik is these options right up here. The plus adds, minus removes. This enables, this disables. So I can disable that. See? It's still in there. It's just non-functional. I can enable it. What I'm going to do is I'm going to go ahead and remove that guy. And right here, I love to add comments to stuff. So this is going to be default route. Right there. So not only is this going to help me in the future when I come back and look at all this stuff, but if I ever have a specific problem and I dump a SUP file out to Mikrotik, they'll be able to see what I'm trying to do, what I'm trying to accomplish, and they'll be able to better understand and fix the problem. So those are routes. Alright, now that we got routes, we've got private addressing on the inside. We've got some RFC 1918 right here, and if we want to go on the internet, you know, route on the public internet, it means we've got a NAT. We got to translate this address to public. So we're going to go IP firewall. This is where all our natting lives. NAT tab right here. Add. So source NAT chain. Source NAT chain is going to be used inside going out. Source NAT. Now by default, if you leave these things null, that means any, which is fine. You can be more specific, so you could drop this down and say source 192.168.1.0. So anybody on my inside going. Now if you leave it just like that, that'll say anybody on the inside going to specific address 0000, which nobody will ever do. You have to remember to add that subnet mask on there, 004/0. So anybody on the inside going outside, remember we could just leave those grayed out. It would work the same. Action. We don't want it to accept, we want it to masquerade, which basically means anything moving through. I'll go ahead and add that route. So now we'd actually be able to get out to the internet. Hosts on the inside would be able to traverse this router and go to the internet. It'll NAT properly. What masquerade means is if I'm coming in this interface, whichever exiting interface I go out, whether it's some interface over here or this interface, use the IP address of that outside interface that you're leaving. So if I leave enter this interface, it's gonna pat port address translate to 1.1.1.1. If this interface had IP 3.3.3.3 and I left it, it would appear as if my traffic was sourced from 3.3.3.3. So that's basically what the masquerade command does. And I mean, that's all you need right there for a functioning router. Routing on the internet, you know, all my hosts can go through. Some additional stuff you're going to want to add probably is a DHCP server on the inside to hand out IP to those inside hosts. So DHCP server. Now I can create pools and then add the DHCP clients and do all that junk, or I can hit this DHCP setup button right here. I want it to go through interface 2 because that's where my users live. Referencing the diagram above. Next, that is the subnet they live on. That is the default gateway. It's the IP of the router. Now, addresses to give out. I usually like to say 20 to the end of the subnet. That way I'll have some room for statics if I want. DNS servers, you know, I'll add my whatever they are. Or actually, if I'm running a caching DNS, 68.1.1, I'll choose the router itself and then I'll give it a tertiary, or a secondary rather, of whatever my ISP provides me. And then least times fine, and then that's it. Now I'm running a DHCP server on the inside. It was that quick and easy. And now it'll be handing out IP addresses. Let's see. If you wanted to do port forwarding, that's another thing a lot of people are interested in. And that's going to be back in our firewall NAT section. Let's see here. Going to add a rule. And again, order of operations is important on this. I don't know if I mentioned that because I don't think I did. But things are processed top down in these lists. So it's going to hit rule 1, and then if it matches that, it'll stop. And it won't go down any further. If it hits this rule, doesn't match, it'll continue to the next rule. And it'll keep going down until it gets a match, or until, you know, it hits the end of the list, and it'll just stop. So I want to do some port forwarding. So we're gonna do yeah, that web server inside. We're gonna forward people destined to them from the outside in destination NAT. And who cares about source address? It can be from anybody on the outside. Destined to the IP of our router because we've only got one IP from our ISP. And we're gonna say protocol TCP destination port. They're heading to port 80. We're going to say action net map. This is just going to map them over to an IP address, and our inside is 192.168.1.3. 2 ports. I want you to go to port 80. Okay. And so since this top rule, our masquerade is inside going out, and this one's outside coming in, it doesn't really matter what our order of operation here is. Remember, a good thing to do is to put comments. Server port 80, and this will be, we'll call it pat outside. So it just makes everything a little bit easier to read, a little bit easier to keep up with. Let's see. And also, this reminds me of something. If I'm this PC right here, 1.2, and I'm trying to get to this web server, and I go to IP 192.168.1.3, you know, in my web browser, it's going to work great. Now, say I have the DNS pointing to this public IP 1111, and I try and browse that URL. With this configuration now, it's actually going to work. Let me see. Is this guy going to work? Yeah, it should work. Because what we're doing is we're masquerading. Because if you get too specific with your masquerade, and you try and go to this guy's IP up here, what it'll do is, if we're not masquerading, mind you, it'll try and go to that public IP. So it'll hit this public IP and it'll NAT back in, right? And so it'll properly hit 192.168.1.3. Well, the source address is still this guy, 192.168.1.2. So my traffic will come here. It'll NAT to, or rather, the destination will NAT to 11113. Okay, I hit that. Oh, okay. Well, then it'll translate back that into my web server. And that's fine. The packet was sourced from 192.168.1.2, so he'll respond to that. So then I'll bypass the router and go straight to here. And so I requested out my TCP session to 1111, and 192.168.1.3 answered. So my three-way handshake won't complete because it didn't come back from the right source. So you always have to remember to masquerade. If you're going to hit these public IPs from the inside like that, you've got to remember to masquerade your traffic properly. That way, whenever I leave, I look like I'm coming from the router. So if I masquerade, you know, 192.168.1.0 to anybody, which is what we want, it'll come in here, and when it exits that interface, it'll look like it's coming from 1.1. So this guy will respond to 1.1, and then he'll translate back to his source address. When it's heading back to me, will be 1111 again, and so the TCP handshake will complete. And that's probably a little outside the scope of this, but threw it in there. Hopefully I thoroughly confused you. Let's see. And that's it for kind of your standard configuration on a router. There's a lot more stuff in there, but I'm going to quickly jump on over to this guy. I'm going to jump over here to the wireless router. Let me put an IP on him real quick. Add address. Yeah, so let's put 68.1.10 on him, /24. And we should be able to specify interface as ether1. Let's print. So that's enabled. You can see it. So we should be able to connect to him with Winbox now. Let me do my little quick trick. 10 and connect. Yeah, there we are. It's a 411A, that's what this guy is. And so, just quickly, you've got the difference with this guy as opposed to 750 is obviously he's only got one Ethernet port and he's got a wireless card in him. And so the wireless tab exists by default and your wireless is disabled right there. So we come in here, you can name the wireless card. I usually like to leave these guys default just for simplicity, because I always, you know, moving from router to router, I like to quickly say ether1, ether2. Wireless. Here's your modes. Your station mode is your default. I've got all the different modes listed there, but really the two I use most are AP bridge and station. And occasionally, if I want to do kind of like a wireless bridge, I'll do station WDS as well. I'll do some WDS in there. But just for the sake of saying it, I'm only going to talk about AP bridge and station. AP bridge, you put what kind of mode you want to be in. If you're doing like a backhaul, you're probably going to use like 5 GHz turbo, so you get a little bit more kick out of it. Your normal wireless cards in your laptop are going to be 2.4, so 2.4 BG if you want like clients to actually be able to connect. Here's where you set your SSID. You can have that to be whatever you want. And security profile, that's how you set up, like, you know, I want them to use WEP or TKIP or, you know, whatever, WPA, all that junk. You're going to set in there. And if you're AP Bridge, you want clients to connect, you just say OK at that point. That's all you got to do. If you actually want to be a client and connect to another AP, you put yourself in station mode, and you set your SSID to that of the remote guy. Security profile is going to need to match something compliant with him. Another cool thing about station mode is you can do scan. That's what it is. Hit scan. Actually, let me enable it first. There we go. Enable, scan it, enable and disable it right there as well. Did I put him in 2.4? No, I left him in 5. Let me 2.4 BG. Apply that, scan. There you go. And so you can actually see some clients out there. This tells you what mode it's in, access point, or rather active, bridge, P's for protected if it's password protected stuff. And so if I see an open AP, I can just click on them and say connect, and it'll actually set my SSID up to that guy, and it'll actually connect me right into him, which I think is pretty cool. Let me expand my screen down a little bit, and now that I'm connected, you see connected to ESS. That means I'm actually bridged onto that guy right now. He's probably running DHCP, so I could enable the DHCP client on this interface and pull an IP and jump right in. But for now, I'm going to hit cancel. I'm going to go ahead and disable that guy back out. So that's your wireless stuff, station mode, security profile. I'll show you that. Oh yeah, if you're AP Bridge and you have people connect, you'll see it pop up in this registration table. Security mode. You can actually, in the registration table, you can see their connection strength and all that good stuff. In here, you can see all of your, like, add a new, see all of your options right here for security. You can do radius authentication on the back end. By the way, Mikrotik can run a radius server by default, and they have a user manager that's really cool interface to configure all that stuff. So let's see, and that's kind of the quick and dirty on the wireless stuff. Let me show you some of the other important quickies, like setting up, or rather backing up your configuration. If you go to files, you can see all the files on here. You can click backup and it'll make this compiled backup file, but I don't really like that because you can't open it up and use it. What you can do is use the export command. Anywhere you can enter a command, you can type export and it'll actually pop out all the, let me show you IP. Export. So it'll actually give you, you can copy and paste this right here, and it'll actually give you everything you need to recreate those commands, you know, the IP address to put all that stuff back in. So what I like to do is use export file, and then you give it a name, and it'll crunch for a second, and when it's done, you'll see this file. You see it's still building right now, but this file backup.rsc exists now, and that's a plain text backup file of all my configurations, so I can copy and paste that back in. And so if I want to back this up, I can just click and drag and drop it into a folder, like on my desktop or anywhere else, and it'll copy it straight out. Also, if I want to upgrade one of my Mikrotiks, you just browse to mikrotik.com, support, download, you know, and then you grab, you know, the combined packages, what I usually use, and you just grab that file from a folder and you drop it in the file list, and it'll upload it. As soon as it's uploaded, you just go system reboot and it'll pull the package. If you just pull the plug and power it back up, it won't actually install that new OS. You actually have to tell the system to reboot, and then it'll shut down. It'll, you know, decompress that file or whatever it has to do. It installs all that stuff, reboots, and comes back up. So it's backing up your config and upgrading the OS. Alright, and this kind of, I got a little bit of stuff in here on bridging, because I do a bit of bridging, so I'll go ahead and show you that. Bridging is technically something, you click right here, bridge, that's done in software, and you use it a lot in like wireless stuff. You're doing wireless WDS, you create bridge interfaces. It's almost like in Cisco, it's like a VLAN interface in theory. If you want to create a loopback in Mikrotik, you just create a bridge interface and stick an IP on it. So you create a bridge interface, ports, and then you just start adding whatever ports you want to be in there. And what that'll do is it'll turn them basically into a switch. The only problem is, like Ethernet, say 5, I want to add to bridge 1. Just say OK. And Ethernet 4, I want to add to bridge 1 as well. So that'll do is that turns those 2 ports into like switch ports, and so they can just L2 stuff to each other. But I can, if I put an IP address on that bridge interface, I can not only switch between those ports, but I can also route back into the router, which is a really cool feature. The only problem is that's all software based, so it means the processor has to handle all that stuff. With some of the newer well, not necessarily newer, the 150s, the 450s, 450Gs, the 750s, and I think like the 493, like that 9-port guy, have switch chips built in. And so what you can do is you can go into interface, and instead of creating bridges, I'll just disable that bridge. You can go in and you choose a master port. So whichever port you want to be master. We'll say we want port 5 to be master. So I'll go into port 4 here, and I'll say master port is port 5. And when I do that and say OK, it turns it into a switch port, only instead of being done in software, it's all done in hardware. So the processor doesn't get involved. Now what that also means is port 4 can't be anything but a switch port. I can't put an IP on it. I can't add it to a bridge or any of that stuff. Wherein, like if I have a bridge interface and these ports are on that bridge interface, I can still put IPs. I can still do crazy stuff with them. Wherein if I make, if I take advantage of the switch chip in there, those switch ASICs, I can't do anything with it except for use it as a switch port anymore. Now at port 5, if he's the master port, I can put an IP on him. I can do all the crazy stuff with him. So, I mean, it's a trade-off, but I think I don't think you're really losing anything there that I've run into. And you see, I'm running version 3. It's still a little early for 4, I think. But it's a little early for 4, but it'll work out. They'll work all the bugs out pretty soon, and I'll be moving up. There's supposed to be additional switching functionality in there. So bridging configuration. So if you want to do like routed interfaces, well, no, VLAN interfaces is what I meant to say. I'm sorry. I was looking at my notes down here. VLAN interfaces, from the interface you can add VLAN right there. You can name it whatever you want. Usually you want it to make sense, so if it's going to be VLAN 10, name it VLAN 10, and VLAN ID right here. Interface, what interface is this attached to? We'll say it's interface 5. Okay, you see it pop down there. Now what this basically does is that just turns it into a switch port. Capable of carrying VLAN tagged 802.1q packets. So if you have like a switch that's set to trunk, you can run multiple VLANs across it, and then this VLAN interface, I can actually create like a bridge interface and bridge multiples of these VLANs across ports. So if I wanted that to carry through to another switch, I could do that, and then I could put an IP on that bridge interface. I mean, it's basically just a whole additional interface you can do whatever you want with. Pops up in here in the interface list, so you could actually assign an IP straight on that guy if you wanted to. So you could route VLAN traffic right there. And you could add multiple VLANs on the same port if you want to. So if you wanted to add VLAN 100 as well. Whoop, add it to the wrong interface. Cool thing about this, you just double click, drop down, put it on 5, you say OK, and there he goes. Easy peasy. Let's see, that kicks on .1q trunking. So let me just run through some of the tools real fast, man, and that'll be it. We'll be out. Put a bow on it. Obviously you can tell there's a whole lot of functionality still left in here that I haven't touched. Let's see, IP scan, I use that occasionally. If I'm having problems, that'll actually, you can specify an interface and an address range, IP/net mask, and it'll, let's see, port 2 I think is the port we got this stuff configured on. 192.168.1.0 is 24, and it'll scan that subnet looking for IPs. See, there you go, give you the MAC addresses and everything. And then if you're having problems with something, you can scan a subnet, and then you can come over here to IP ARP, make sure they're popping up in the ARP table, all that good stuff. Just your basic troubleshooting tools. I use IP scan. Let's see, I use torch. Well, I use ping a whole lot, obviously. When I'm testing, I do a whole lot of IPsec stuff, so I use ping extensively, because I'll ping something on the remote gateway. Say they're 192.168.2.1. That's the subnet through my IPsec tunnel on the other side. Then I'll specify the inside interface to come from. That way it'll source the traffic from the inside so that it looks like interesting traffic and will actually traverse the tunnel. So I use that a lot. Let's see, we got, oops, accidentally hit radius there. Tools, torch, this is another good one that I use occasionally. And this is going to be like TCP dump in Linux is basically what this equivalent is. You're able to put in interface, source, destination. You can get protocols, ports, all that good stuff in there, and you can have it sniff just to see what's going on. So if you're working on firewall rules, or again some IPsec stuff, you'll be able to see is it actually entering my router, is it traversing my router, all that good stuff. So it kind of gives you some additional functionality there. Let's see, bandwidth test, I like that a lot too for testing stuff. Tools, because you have bandwidth test server, which by default is enabled, but it's enabled for authentication. So occasionally you'll get script kiddies out there will hit the port and you'll see a failed authentication of some weird garbled stuff. So you'll want to disable that, which that's going to be in my security one as well. But tools, bandwidth test, what this allows you to do is put in your destination Mikrotik, choose the protocol you want, direction, it'll actually do a bandwidth test. If you just leave it unrestricted, it'll pull as much bandwidth as it can. So it's a good way to see how much throughput you can get through your stuff. They also have a Windows client that'll allow you to connect to these bandwidth test servers, but I've seen that to be somewhat unreliable just because of the Windows operating system. And you got your normal traceroute utilities in there. Let's see, you can telnet. So if you're on, here it is, telnet, they'll actually allow you to telnet or SSH, but you can also MAC telnet to another Mikrotik. Get the drop down, and there's all the other guys he sees on that subnet. So then you can just MAC telnet straight to another one. It gives you command line interface over there too. And the last slide is going to be some resources to my blog, to Cacti. If you've never used Cacti, Cacti Easy, it's completely free and it monitors everything you can think of. I hope you enjoyed this. I know it was a little light, but I plan on offering several of these, with kind of directed content. So hopefully I'll get to one you're more interested in soon, if this one didn't do it for you. Thanks. Drop by the blog, leave me some comments, drop me any questions. Thanks, guys.